Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, and viewers. Here are another set of problems in calculus about derivative of functions interpreted as slope, but we just estimate the slope based on the curve. And for part A, we have accurate slope. So if 1A, if f of x is x over 1 plus 2x, find f prime of a. So meaning the derivative of f with this f at x equals a, and use it to find an equation of the tangent line to the curve y equals x over 1 plus 2x, same as that, at the point quantity 1 negative 1/4 comma negative 1/2, because when x is negative 1/4, if you evaluate this expression here or this curve here, when x is negative 1/4, negative 1/4 over 1 plus 2 times negative 1/4, so this is negative uh, 1/2 plus 1, so 1/2, negative 1/4 over 1/2 is negative 1/2. So illustrate part B, illustrate part A by graphing the curve and the tangent line on the same screen. So let's concentrate to focus this problem first. So f of x is x over 1 plus 2x. So this our guide would be derivative of fraction, numerator over denominator, or u over v, which is denominator times derivative of numerator with respect to x, minus numerator times derivative of denominator all over denominator square. So f prime of x is denominator 1 plus 2x, derivative of x with respect to x is 1, minus numerator, which is x, times the derivative of the denominator, which is 2. Then all over denominator square, 1 plus 2x quantity square. So if this is 1 plus 2x minus 2x, so simplifying, the numerator will just be 1 and the denominator will be 1 plus 2x quantity square. So therefore, the value of the derivative when x is a, f prime of a, derivative of the function, we simply substitute x is a, so 1 over quantity 1 plus 2a squared. So that's the answer to part 1a. Then part B, this is now the specific value. So f prime of a is f prime of negative 1/4, because the point has x equals negative 1/4, and it is equal to 4 from here. So 1 over quantity 1 plus 2 times negative 1/4, then close square. This is 1/2. So 1 over 1/2 square is 1 over 1/4, and 1 over 1/4 is 4. That's why it's 4. Then 1b, we have this point by point slope form, y minus y1, which is negative 1/2, equals slope 4, then slope 4, then quantity x minus x1, so x minus negative 1/4. So simplifying, y plus 1/2 equals 4 times x by distribution, 4x, this is positive 1/4 plus 1. So simplifying further, tangent is y equals 4x, 1 minus 1/2 is 1/2. This is the y-intercept, the slope is 4, and the graph is shown here. So this is the graph of y equals x over 1 plus 2x. To prepare this graph, all we have to do is we have a vertical asymptote when x is, this makes 0 when x is negative 1 half. So that's why when x is negative 1 half or negative 0.5, so just to the left, for example, negative 0.50001, the value of y would be large positive, so it approaches positive infinity. Then when x is negative 0.499999, substitute here, evaluate this ratio, that's negative infinity. So it is approaching negative infinity, and this is the vertical asymptote. Then for some other values, negative 1 for example, this is negative 1 over 1 plus 2 times negative 1, so that's why we have positive 1 there. When x is negative 1.5, uh, negative 1.5 over negative 1.5 over negative 2, so negative 0.75, negative 0.75 there. When x is negative 2, this is negative 3. So negative 2 over negative 3 is positive 2/3. So that's 0.6667 approximately, and so on and so forth. So I just present or view this portion because the tangent is the tangent at the point negative 1/4 comma negative 0.5, which is this. Then when x is 0, 0 over 1 is 0. When x is 1 half, 0.5 over 1 plus 2 times 0.5, 0.5 over 2 is 0.25 here. When x is 1, 1 over 1 plus 2 times 1, 1/3. So 1/3 is 0.333, and 1.5 over 4, 0.375. Then when x is 2, 2 over 1 plus 1 plus 2 times 2, so 2 over 5.4, and so on and so forth. So I think this portion of the graph would be enough. And let's have the tangent now, which is 4x plus 1 half. The slope is 4, so this is 2.5 minus 0.52, 2 divided by 0.5, so is 4. So that's why this line has a slope of 4, and it is tangent to this point. So that's y equals 4x plus 1 half. Let's proceed to problem 2. If let g of x be 3 to the x, estimate the value of g prime at 1 using limits, not by derivatives, and taking successively smaller values of h by zooming in on the graph of 3 to the x and estimating the slope. So 2b, 2a rather. So g prime of a is limit of 3 to the, we replace this by a plus delta x, or x plus delta x supposedly, in particular a plus h, then minus 3 to the a all over h, because we have g prime of a here, but h approaches 0. So that's the slope supposedly using limits. So slope limit of, as h approaches 0, of 3 to the, because we have g prime at 1, so 3 to the 1 plus h minus 3 to the 1 over h. Factor out 3. So this is 3 to the 1 times quantity 3 to the h minus 1 all over h as h approaches 0. So take note that 3 to the 1 plus h is like 3 to the h times 3 to the 1, or 3 times 3 to the h. So this is now the factored form of the numerator. Then we set the value of h and evaluate 3 over 3 to the h minus 1 all over h using your calculator. When h is close to 0, 0.01, it's 3.314. 0.001, evaluate this, so 3.298. At 0.0001, it's 3.296. This is the closest. At negative 0.0001, it's 3.296 also. Negative 0.001, it's 3.294. At negative 0.01, 3.278. So that means G prime at 1 is, because this is very close to 0, it is 3.296 using limits. Then this 2b here, or 2b, by zooming in on the graph 3 to the x, so we have to plot the graph of exponential function because we dealt with algebraic functions yet, so we have to sketch the graph of this by point plotting, although you should be familiar with the graph of exponential functions from your algebra experience. But I assume that uh, you're not yet familiar with that, or with that of exponential function or graphs of exponential function. So we have to plot points. So we have to begin with negative 2. It is 0.11. So that's why we have 0.11 that. At negative 1.5, 0.192. Negative 1, 1/3 or 0.333. Negative zero point 0.5, it's 0.577. At x is 0, it is 1. 0.5, 1.732. At 1, 3, so it's 3 there. At 1.5, 5.196, 5.196, or almost 5.2. At 2, it is 9. So this part on the screen would be enough to show that the slope when x is 1, which is somewhere here, is, because this is 0.5, we have to estimate that vertical distance, that vertical distance of the tangent, that's the tangent. So the tangent is made tangent to this. So if that's enough, or you're satisfied with that tangent, then we have to estimate this. So this is approximately 1.65. So 1.65 is 4.65. We have to estimate that, magnify that part over 0.5. So slope therefore is 1.65 or 0.5. Slope is 3.3 based on the figure, and it is an estimate. So m equals d prime when x is 1 and it is 3.3. That's estimated. That's not the exact value. This is the value when h approaches 0, and later on, if actually the slope is supposedly 3 to the x, the derivative is 3 to the x ln of 3, and 3 to the 1 ln of 3, that's about, you may just evaluate that. So that's it for 2b. Then 3, let f of x equals tangent x. Estimate the value of f prime at pi over 4 using limits and taking successively smaller values of h. By zooming in on the graph of y equals tangent x and estimating the slope. So this is similar to problem 2, but we are dealing with tangent x. So portion of the graph of tangent x, by zooming in, will just be this part here. Remember, the graph of tangent x looks like this. So negative infinity when x approaches negative pi over 4 from the pi over 2 rather from the left. Then it is approaching positive infinity when x approaches pi over 2 from the left. Then approaching negative infinity when x approaches, the value approaches negative infinity when x approaches negative pi over 2. So when x is 0, tangent of 0 is 0, then 3b, 3a. These are the tabulated values also. That's the graph of tangent. Other values to consider. So we have 0, 0, pi over 8, tangent of pi over 8 is 0.414. So here, this is pi over 8. Then this is pi over 4. Pi over 4. 1. Tangent of pi over 4, tangent 45 is 1. So that's why it's 1 there. And tangent of 3 pi over 8 is 2.414. That's 2.414. And tangent of value just to the left of pi over 2 is positive infinity. That's why it rises there. So this is the point of tangency at pi over 4. And tangent of pi over 4 is 1. So next is we draw this tangent line and estimate later the slope. So let's have f prime of a, which is limit as h approaches a of tangent of quantity a plus h. So we replace x here by a plus h, where h approaches 0 minus original tangent of a over h. Then let's evaluate this for values, smaller and smaller values. So we begin with 0.01. Then the value here at the right is 2.0200. At 0.001, it is 2.002. So there is now a pattern that when h approaches 0, it is 2 because the value is close to 2. So meaning to say, the derivative of tangent x is supposedly secant square x, if you know, but we are asked or tasked to just evaluate using limits. So the derivative is supposed to be 2 when x is pi over 4. But we just move on. So at negative 0.001, 1.998, negative 0.001, 1.998, and negative 0.01, 1.9803. So we conclude that f prime of at pi over 4 is equal to 2. Although it's 2.002 here, but we have to round off values to just 3 decimal places, so that's why it's 2. Then, by estimating, this is the tangent. So because this is 1 and pi over 4 here, so this value upon estimating horizontally is 1.28. So 1.28 is based on my estimate here at this point here. You may modify this further. Then this is pi over 4 when x is pi over 4. That's why it's tangent of pi over 4 is 1. So slope based on estimates is 1 over quantity 1.28 minus pi over 4. And that's 2.022. That's the estimated value. So that's it for this problem. This is the actual slope 2.